Welcome back to Summarize Science. Today we are looking at a breakthrough in 3D rendering called Matryoshka Gaussian Splatting. Imagine trying to run a high-end video game on a smartphone. Usually, you have to sacrifice a lot of visual detail to keep things running smoothly. Researchers have developed a new way to handle level of detail, which is how computers decide how much effort to put into drawing a scene. Traditionally, this is done in chunky steps that can cause objects to pop into view distractingly. This new method allows for a perfectly smooth transition between low and high quality. The system learns an ordered set of 3D shapes called Gaussians or splats. Think of these like digital paint strokes that build up a complex 3D image. The researchers named it after Matryoshka dolls because the lower quality versions are tucked inside the higher quality ones. The core idea is to create a single 3D model that can adapt to any budget of processing power. Instead of needing different versions of a scene for a phone and a PC, this one model handles everything. It provides a dense continuum of quality, meaning it can be adjusted bit by bit to fit the device perfectly. The magic happens by ranking these splats based on how important they are to the final image. By putting the most important ones first, the computer can stop rendering at any point and still show a coherent picture. A pixel color is calculated by blending these splats together from front to back. During training, the system is challenged with random budgets of splats to ensure it performs well no matter how much power is available. This is called stochastic budget training, which means the model learns to be efficient and high quality at the same time. They found that sorting splats by opacity, how solid they look, was the most stable way to order them. The study evaluated this new method across 4 major benchmarks used by graphics experts. They compared it against 6 other leading methods to see which one offered the best trade-off between speed and beauty. When looking at the data, the new method consistently landed in the top spots for image quality. It achieves high marks in technical scores like PSNR and SSM, which measure how close a digital render is to a real photo. You can see how the quality stays high even when the frame rate increases significantly. On the right, the graph shows that as more splats are added, the quality improves in a smooth, predictable curve. This is much better than previous methods that often crashed in quality when they tried to go too fast. Looking at these visual comparisons, the top row shows how the new method maintains a clear image even with only 5% of the data. Other methods on the bottom rows tend to look blurry or broken when they are forced to work with less information. This level of clarity at low power is a massive leap forward for mobile technology. Even in complex environments like forests or ruins, the details hold up remarkably well. The system even handles failure cases more gracefully than its competitors, avoiding the shattered glass look of older techniques. To recap, this research provides a way to have one single 3D model that works on everything from a powerful workstation to a mobile phone. It eliminates the need for pop-in artifacts where objects suddenly change as you get closer to them in a game. In the future, this could lead to much more realistic virtual worlds that adapt instantly to your device's battery life or processing power. Thanks for watching Summarize Science, and we will see you next time.